Okay, well, welcome everyone to the Analytics That Matter podcast. This is a series that we do frequently during our monthly sessions. We get together and talk about a particular topic in the field of analytics related to manufacturing. Today's topic that we would like to talk about and the question we pose is how to approach the creating analytics for difficult to measure manufacturing metrics. It's pretty important in that, when you start bringing together all sorts of different types of manufacturing data, lots of different data sets, the volumes of data, the different frequencies of that data, different time horizons, different events that generate that data, how do you bring that together? How do you normalize that data? And then how do you get some of that data that's difficult to measure? And there's a lot of different definitions for difficult to measure. Joining us today with our typical team here for the analytics working group, which includes Larry White and John Jackiu and Alex, and we have Matthew with us as well. Also members of our team, we have Vivek, we have Satish, and JP. Is that correct, JP?
Yeah, that's good.
Okay, so that's why I see you listed here. So, but joining us as a guest, we have Kip Crumweed. Is that correct? Crumweedy. I apologize. So Kip is going to give us some background. He's been working in this area quite a bit, dealing with some of these thorny issues about bringing in getting measurements that are difficult to obtain in manufacturing and then providing valuable analytics out of it. What are the challenges? What are the benefits? He's going to give us a little background on what his experiences, and then we're going to share with him some of our insights and ask him some intelligent questions from this group. With that, Kip, I'm going to stop sharing for a moment and let you take it away.
All right. Okay.
Looks like it started to share. Excellent. I see a screen. Okay. One thing I'm seeing the speaker's side of the presentation. Yeah, there you go. Perfect.
There we go.
How's that?
Yep, you got it.
All right. Yeah, thanks everyone for having me today. It's my pleasure to be with you. I've worked with Larry quite a bit over the years through IMA, and he's often mentioned this group and the great discussions that you have. And so I am really interested in what your thoughts on the topic of measurement. And so I'll just say, previous to this, I was director of research for IMA for several years. And before that, accounting professor focusing on management accounting, including measurement. And for the last 6 months or so, I've been working as a consultant, helping companies in this area and related areas, strategic planning, et cetera. The main message I'd like to suggest today is that measurement is really about reducing uncertainty. So if we look at it that way, then that's the basis for really essentially anything can be measured. You can often make useful inferences about things based on a small amount of observations, and anything that can be observed can be measured. And anything that can be measured can be modeled and therefore used to even forecast the future. But if any information that can potentially reduce uncertainty is to be added, to be measured, maybe added to a predictive model, it means it has to be measurable in some way. And so let's get into that here a little bit. So let me fix this on this side here. All right. Yeah, as you know, there's just so much more data available these days, and even social media and Google search data is being used in forecasting models and for KPIs. But yet it's hard to imagine in a lot of cases using that data or finding any type of benefit out of it. One example, a music company using search data for different genres to predict which genres are going to be most in demand and predict the royalty splits. CPE provider assessing its innovativeness versus social media likes. All right. Those are just some broad examples. So make this a little interactive. I'd like to ask, just throw the question out, are there any uncertainties that seem impossible for you to measure in your businesses?
If you'd like, this is John Jacquio. If you'd like me to lead on that, I think the only uncertainties that are impossible to measure are a function of cost or what you're expecting to use that information for. And sometimes we actually bank information, not bank information, yeah, actually data bank information with the anticipation that we don't always know what that information is that we need. And then we'll then start correlating and cross-correlating that data and remodeling it in order to be able to find or create an understanding of something that was unseen or previously unpredictable. So, I mean, that's kind of where my thinking is. I mean, when the topic of, how do we reduce the information, how do we look at information as to what's unmeasurable is really only a matter of time and how we're going to measure that, I think. Does anyone disagree with me? I think Matthew Littlefield, you've been, and we've been involved in many of these topic discussions over the years. I'd love to hear your take on this topic.
Thanks, John. I think a lot of manufacturers are really good at measurement. They collect a lot of data. They track a lot of data. The thing that often seems impossible to a lot of manufacturers, not necessarily impossible, but hard, is sometimes cutting through that deluge of data. What's the important signal, the signal in the noise? So that's a challenge. And then often, data is trapped in different silos, in different systems, and then bringing data together from different systems in a way where you can easily match those different data sources together to draw analysis is difficult or near impossible for many manufacturers. And even if it is possible, the time, energy, effort, cost to do the measurement and do the analysis is too great to justify all the work often.
I'd actually like to challenge that too great to justify comment, because I think, this is a personal opinion here, but I think it's only a matter of time before someone sees a value in something and starts to remodel it. I mean, look where we were with 3D models of plants. I work here with Dassault Systems, and we constantly employ digital twins, the 3D experience, putting all of these pieces together to create and merge the data with visualization, understanding how, and then when the data starts to manipulate the visualization, it's pretty interesting. I'm going to switch the topic a little bit here, because you had, Kip, you had brought in social media. I've been involved in several projects where some of the customers that I've worked with have brought in social media and information on how a rainstorm affects what someone's going to buy in a grocery store. Therefore, it's going to impact what we have to manufacture, because we can predict the weather. Now that we can predict the weather, how do we look at predicting what we need to manufacture for the most consumption without running out? And I'll invite anybody else to comment on that.
Well, and I mean, that's really the ultimate, John, is the prediction of demand. I mean, when you get down to business problem number one, it's really about predicting demand so that you don't waste any resources overproducing and you don't miss out on any revenue opportunities by underproducing for your market. So demand is of course really the ultimate prediction challenge. Kip, do you have any thoughts on that?
Yeah, well, definitely. You know, the one thing about predicting the weather is, yeah, we can predict it, but it's usually too late. I mean, if it's raining now, we might not be able to make changes in what we plan to produce. Now, we might have some long-term forecasts and things like that. But I would agree that one of the most important things we can try to measure is demand and to try and forecast it. And that was a area I'd like to get into next. I appreciate all the examples that you've given, and we'll probably include those in our discussion. But let me just kind of take this a little bit farther about how anything can be measured. And I'm a real proponent of this book by Douglas Hubbard, How to Measure Anything. And so really, the key points of this is that there's three main arguments that some things just cannot be measured. There's the concept of measurement being misunderstood. Instead, if we look at measurement as a quantitatively expressed reduction in uncertainty based on observation, then all of a sudden that releases a lot of things that can be measured that maybe we thought couldn't be measured. There's also the object of measurement. The thing we're actually trying to measure is often not well defined. So if you're not sure how to measure something, ask the question, well, what would more or less of it look like? And I'll have an example next. And then the third major argument that some things can't be measured is the method of measurement. It's really broader than traditionally thought. Measurement does not have to be based on data necessarily. As defined above in the first item, it can be based on observation. So if someone says, we just can't measure that because there's no way to put a number on it, we can say, well, if it can be observed, it can be measured. An example I like to give is several years ago, the US Department of Veterans Affairs CIO Council was trying to define IT security because they were contemplating some new systems, and improvement in IT security had to be part of the decision making. The traditional approach to measure IT security was just kind of basic things like how many people had completed security training courses and how many desktops had certain security systems installed. So it really wasn't measuring IT security or what improved IT security would look like. It was just measuring some of the inputs. So there were three main questions that were asked in this case to try and nail this down. First of all, what is this decision for? Now that came up earlier in our discussion. John mentioned cost, and often, you know, what is the right cost to use for each decision, or what is this decision for is always a key question in any type of measurement. The next question was, what do you mean by IT security? So this forces you to really articulate, what are we talking about here? What would it look like if it were improved? And then third question is follow up on that. What does improved IT security look like? So the answers to these questions, what is it for? They were considering major improvements in IT security. So they're contemplating different options, very expensive systems. And so that's specifically what the measurement was for. What do you mean by IT security? Well, everyone had a different opinion, but the facilitator was able to get them to really hone in on certain security systems that they wanted to focus on. They came up with a list of potential events related to IT security, whether it were cyber attacks or even physical access, even weather-related incidents that could cause a problem. And then the costs averted. So they made a specific list of costs that they were trying to avert related to those events. And once you answered those first two questions, the third question was a lot easier to answer. It was essentially reduction in frequency and severity of certain specific events that they had identified and the costs related. So that's an example of how we can approach a question of something that just seems hard to measure. Now, we've gotten a little bit into all the just different types of sources there are now of data, you know, the Internet of Things, and there's just so much. This was a list put together that just gives some examples of things that really, most of these are relatively new historically for analysis. You see like credit card transactions on here. What I had, let's see, accounts receivable. Well, anyway, I thought I had, but let's say we have credit card transaction data, all right, through our payment process. And earlier it was mentioned challenges having data on different systems. And that's no doubt a big problem. To the extent that we can integrate our different systems, at least into some kind of data lake, so to speak, where we can connect different types of data. For instance, if we have this credit card transaction data and we can somehow match it with customer management type data, you know, getting an idea of which customers are the biggest customers, the most satisfied customers. If we can match that with credit card transactions, maybe we can get an idea of which customers are using which kinds of transactions, are the customers that we don't care about as much using these payment channels, or kind of a different tack if we've got data on happy customer versus an unhappy customer. One is late, let's say they're both late on payments. We might be able to approach a happy customer a little differently than we'd approach an unhappy customer. And so that's just an example of how, if we can integrate different types of data, we can get at the types of decisions that we just didn't think were really possible before. Getting to demand here, there was an article in Strategic Finance published by IMA last year that I thought was really terrific. It talked about disaggregating demand forecasting. Now, first of all, forecasting demand is often not really what we do. We tend to forecast sales and assume that represents demand, but demand for our product is not necessarily sales. And we might have more demand than we can actually meet. And so if we want to try to manage that demand, we want to try to fill demand that's going to be the best for us, but it's unpredictable. However, if we can break up total demand into, let's say, predictable demand, customers and businesses that we have contracts with, we're pretty sure they're going to renew the contract. We know the costs and the types of things we have to do for them, and we know what they're interested in. That can be fairly predictable. But then there's a lot of conditional demand that is not predictable. Those are things that are based on some event or a certain condition. So let's say that we break up our conditional demand into two pieces, each one with its own source. The first one, the demand is contingent on a competitor's sales promotion. We estimate the probability at 90%. We think it's going to happen in February 2022. And if that does happen, we foresee a drop in demand for our product by 10%. Well, if it's a high probability, that's something we might want to build into our demand forecast and even our planning for what we're going to produce. The second source, more of a weather, and we talked about weather earlier. Let's say that if there's a spring dry weather event, which we estimate a probability of 30% in April, if that happens, then that will increase demand for our product by 20%. Well, if it's only probability of 30%, we might not build that into our financial forecast, but in our scenario planning, it's important to know that there's almost, a third, 30% chance that we're going to have this huge demand impact, and that might impact our planning and the quantity that we plan to produce. So let's stop at that point and take any examples you have or thoughts on what I've just been talking about.
I'd say, Kip, first off, let me just say has been very interesting. One of the things that I took away to start off, and especially after you presented the example from the IT security initiative at the Veterans Affairs, is that when we talk about measurement, and certainly when we talk about that in the context of analytics, we really do need to start with the end in mind and define what we mean by measurement. Define it at the highest level. What are the outcomes that we're looking to seek? Because that drives then what you are looking to collect as far as data, what you're looking to measure. So before you throw up your hands and decide that things are not measurable, you really need to get to the root of what it is that you're trying to drive as far as an end game and solution, an analytic, a business improvement, and then decide what is the real relevant data you need to grab. Because in that instance, you may hone it down to sources of data that are measurable in some way or form, or at least come up with the methodologies to do those measurements and focus in on, again, driving the end game. That's something we've talked about in this group over and over again, is really keeping the end in mind, and that some of the business fundamentals that we've dealt with through our entire careers haven't changed just because of data analytics and all these new technologies. And that seems to be still ringing true right here. So I'll stop there and let others add as well to this.
Well, let me kind of build on what you just said, Chris. And it's not always about looking at what the end in mind is. It could be looking simply at trends. It could be simply looking for discovery. We don't always know what we're looking for, but when we see it, we know it. That's part of that's part of something that the human brain is very, very good at, and being able to tie together different silos and breaking apart the data. We keep on thinking about this as a data problem, and I'm going to disagree with that. Data is the data. It's a matter of what we do with it, how we model it, and how we create an understanding that gets us to move forward. I mean, how do we take I think Matthew mentioned that, we have these different silos of data that are locked together. If we unlock those silos and put them together in a different way that we didn't see before, we've made careers, folks, out of finding things that are unmeasurable and finding a way to measure it, or finding a problem that is unsolvable and solving it. And that's what that's what we've all been doing within engineering. And I mean, I'm not sure where we want this to go, but it's a matter of, how do we start looking at data differently? How are things like artificial intelligence and unstructured, being able to take in unstructured data and have trends come out of it that were not seen before is kind of where my head's at these days.
Yeah, John, that's a really good point. And the other issue is, sometimes when you look at the information and when you define the information you want, you're sometimes kind of quick to grab at data. And there's a dimension to data quality that goes to what I like to call its fit for purpose. I mean, this is particularly hazardous from the accounting world, because financial data, while it's known for its quality, that quality is evaluated with a specific purpose, and that purpose is financial reporting rules. Whereas, when you're looking at a lot of financial information for applying it to manufacturing metrics, what you're really interested in is the causal relationship. Do the financial numbers move in such a way that they reflect the causal relationships that are going on in manufacturing? And I know in particular, as manufacturing becomes incredibly granular in its ability to measure things, a great deal of financial information just doesn't keep up. So when you just grab data that looks fit for purpose, you have to really consider, are you getting an answer that's going to make cause and effect sense when you go to make a decision?
I think that's a very valid point, considering the fact that you have to look at the time limits of certain data. As it aged, is it aged past its due? How do you use the data and the aging data in each one of the conditions moving forward is part of the issue also. And I mean, whether it's understanding the machine cost when you're consuming product based on the end of last month's spend, or is it really the spend for the current line side product that you've just replenished with? You need to be able to create alignment relative to the age of the data also. So there's a lot of that when it comes to the modeling and how you build the models, especially if you're starting to do things like like building digital twins and modeling not only the functional movement of machinery, product, and the human capacity within that model, but you're also looking at the financial cost, as well as all of the data that's flowing through there. And oftentimes at the factory level, it's flying through there at lightning speed with incredible volumes of data.
Yeah, and you have to be careful if you're dealing with real-time manufacturing data and you're dealing with estimated, I'm going to call it monetary, because financial kind of gets around the financial reporting data, and here I'm just using monetary data. You might have a mismatch where the manufacturing information is going to change based on a situation, whereas if the other data, the financial data is kind of has a number of estimates or big things pulled together and isn't nearly as granular, it may not change in a manner that reflects the manufacturing data.
Absolutely. I'm sorry, go ahead.
I was going to say, I think a lot of times companies will build metrics around use cases or functional areas. So they might have quality metrics or inventory metrics or maintenance metrics, which is great, but they won't take the time to build that out by persona or by user. And so the quality metrics for an operator are going to be different than for a supervisor. They're going to be different for a quality engineer versus supply chain business analyst versus maybe somebody who's doing supplier management, right, and trying to think about supplier quality. So quality is a thread that goes between those, but the timeframes and the type of data and how long they have to make decisions are all different for each of those different users. So tying together both use cases and users I think is important for a lot of manufacturers, and that often gets missed. They just say, here's the quality metric, and then everyone looks at the same metric, but it might not be relevant to all the roles in the same way.
Yeah, and I think what you said about time, the time frame of the decision, the time frame of the data you're analyzing. Somebody one time said, I think it was in a Mesa forum, that the difference between manufacturing data is it's meant to make decisions now, whereas a lot of accounting and financial data, it's reported 3 weeks late and you're given 6 weeks to fix it.
Yeah, exactly. Right. If you're an operator, quality matters right now, in the next 5 minutes. If you're an engineer, right, you might be looking at months worth of data to try and find some systemic issue
Yeah.
to correct. So
Yeah.
time is a big part of it.
Yeah, I think you guys are touching on something that's really, really important when we were talking about personas. And this goes back to, I think, even the siloing behavior that we have. It's really good that I think we're all talking about building the personas and understanding quality as a near-term metric, and then finance and everything else. Yeah, there's been many jokes I have heard about finance. Yeah, it gets data that's 3 weeks old, has 6 weeks to figure it out, to tell people what they did 3 months ago. But I think one of the things we're ignoring here, or maybe just kind of talking around, is how do we take this data and turn it into real metrics or measures that we can use to make decisions. And we're all talking about, I think, data, and we're really focused on what we could do with the computer. But what do you guys think would be another source? Like for me, honestly, some of the more experienced guys on the shop floor, I think, could actually give you a lot of information, or give you an idea of what metrics you can look at in order to improve your product or process. And maybe we can riff on that for a little bit.
I think there's a whole untapped area of untapped information and unestablished metrics. I mean, especially on the manufacturing floor, if you take a look at where a majority of manufacturers are, if you sit there and look at the sort of industry 3.0, industry 4.0 scope, a lot of people are probably sitting somewhere in that, industry 2.8, 2.9, call it 3 space, right? And in that space, all the focus was on automating the process and not necessarily getting, data out of equipment where you needed to fully define your processes and really start, really develop models around whatever your process is and your equipment is, right? To be able to leverage that and get, actionable information on that. Yeah, we have, CMMS systems, and we have MES, and we have ERP, right? But those are really just, helping us orchestrate the operations of the business. But when it really comes to trying to provide value to the shop floor and increase those efficiencies, I think there's a whole untapped area where we're, the data points don't even exist. People have to architect some of that stuff, right?
Yeah. Sorry, go ahead.
Yeah, Satish here. I just wanted to add what JP was saying. So I'm a manufacturing analytics consultant based out of India. So I also experience the same, like there are immense opportunities at the automation level. That is the level 1, where the census data are left at the controller level, and it's not captured for any analysis or modeling. So if we collect those data and focus on those collection of those data and automating the census data at the controller level, there are like different controllers, Allen Bradley and Siemens and all. So there are immense opportunities to collect this data and do a lot of different kinds of modeling, like predictive modeling. So that is like predictive modeling has immense opportunities in process as well as in the equipment's both, because equipment's failure, if we can predict, so that will help in the manufacturing aspects a lot. So that is the one point I just wanted to mention. Thank you.
Thanks, Satish. One response maybe to Alex's comment around, why is that experienced operator or mechanic sort of perceived as a better source of real insights and information than the metric system or whatever dashboard you're using. And I think the reason's because that experienced operator or mechanic has been in a learning cycle for a long time. And what a lot of our metrics programs are, they're open loop, not closed loop, and they're focused on basically getting to the prediction, but they don't make a prescription and they don't look at the prognosis and close that as part of a learning system. So I might know that asset might fail in the future, but I don't necessarily know what to do about it. And then when I do take that action, I don't go back and look, hey, did I get the result I expected from taking that action? Did I learn based on that? And then refine the model over time. So I think a lot of companies are just open looping their metrics, looking at predictions and not actually changing actions. And then not saying, hey, based on that change, did I get better or worse? And then improve for the next time. So the people, the operators, the mechanics, they're on this continuous learning cycle. The metrics programs are just shooting out prediction, green light, red light, yellow light, but not actually learning and improving over time.
Let me jump in if that's okay. And what we've been talking about prediction here, and I really have enjoyed all of your comments. And let me point out one thing here about breaking out a forecast into different pieces. Larry talked about causal relationships. If we break out a forecast into individual pieces, it tends to give us a more accurate forecast, tends to cancel out forecast error inherent in just a single prediction, and it recognizes that different factors can affect the outcome. And I had one last example here. I've been working on a demand forecast for Tesla for quite a while, and if we this is a good example of a cause and effect chain and how we can maybe use some non-traditional data to get to our ultimate purpose. It's been challenging to forecast the demand for electric vehicles. It's slowly being more accepted in the US, but there's lots of issues. But for Tesla, they could start off with an operational type metric like the battery storage capacity. And they, through analysis, find that there's a relationship between if we increase the storage capacity, that increases the range of the electric vehicle, which is important to consumers. And the more we can increase the range, the more Tesla will get of that market share. In another path here, causal path, charging stations is a big issue, and not having enough, and people aren't sure they're going to be able to charge their car. But if Tesla has really focused on building these fast charge stations that can charge a vehicle within 15 minutes or so, rather than overnight in the garage. And so they can find the relationship between, okay, if we increase fast charge stations, that's going to actually increase traffic onto the website. They sell most of their vehicles online rather than through dealerships. And the more traffic online, especially unique visitors, that also has a relationship with Tesla's market share. Now, there's individual pieces we can break this into further. This is a bit generalized, but it gives the idea that we need to look for cause and effect factors in a chain that can ultimately link to the decision. In this case, the decision they're trying to make is, okay, based on what we think demand will be, how many different types of EV models should we produce this upcoming year? So one other linkage I'll talk about is the more non-Tesla fast charge stations increase, the more consumer acceptance of electric vehicles And that increases the market demand overall for electric vehicles. And it might seem odd that the increase of non-Tesla fast charge stations could improve demand for Teslas, but it has a social impact by making consumers more comfortable that they'll be able to charge their electric vehicle. So the pie gets bigger. The first two paths are about Tesla's market share of the pie. The third one is the pie getting larger, and that's going to improve demand for Tesla. So ultimately, we can link this to ultimately what we're trying to get is the forecasted demand for cars, so we know how many to produce. We can take the Tesla market share times this total market demand and be able to estimate forecasted demand for the vehicles. Again, this is highly simplified, but it just gives an idea of how we can link different types of data and ultimately to the decision that we're trying to make. So if you're trying to do something like this, a good way to start is at the end. Ultimately, what are we trying to get to? Well, forecasted demand. Well, what makes up that? You know, what's the next step back? Well, it's market share and it's demand for electric vehicles. Then we take a step back from that. Okay, what drives each of these items? And so that helps us to focus on the measures that really get us to the information, the data that we're trying to get. So that's all I got for you. I'll turn the time back to you guys. I'm anxious to hear your thoughts on this or anything else.
Well, let me start by first of all complimenting you on the merging of information that you have. You've now taken the construct around manufacturing battery storage capacities, as well as fast charge and general recharge stations that are available, consumer confidence, social media, and market share, and put them together into a single model. So you've taken things that, frankly, 10 years ago would have been impossible to link and connect, and you've now connected them. So I first of all compliment you. And I think the one thing that I'm seeing in this is something that I started mentioning earlier. Not always is there a decision point, but you're looking at the trends in the ability to create a great website. Are people going to use it? And that's going to also be another factor in the link to market share. Mm-hmm. So, you know, you're connecting many, many facets of many pieces of data here. And this is why I think companies like Tesla, a lot of the automotives, and many, many other companies are starting to look at and create roles that are called strategic analytics officers or chief analytics officers that are driving us to not only look at manufacturing information, manufacturing data, but it's about having a unified modeled approach. Now, we discussed this in the Mesa manufacturing analytics book that was recently released. But this goes, what you've done here really helps to codify, I think, some of the things that we talked about in that book also.
Thank you.
Anyone else?
No, 100%, John. I would say that this is a great example of what we were talking about in a very concise way with a good set of examples. So, Kip, this was great. A great way to kind of do a deep dive, but at the same time make it tangible and accessible to people so that they can understand both the challenges, but also the value proposition of where we are headed right now when we talk about analytics and bringing together all this data, why it's important, why it's a game changer, how it's a business differentiator, etc.
You know, there's another there's several other paths here in the overall demand forecast model, but one like leading indicator of demand for electric vehicles could be something totally unrelated to electric vehicles, and that is the number of solar panels installed on households. as an idea of the environmental consciousness of the people of the country that you're trying to forecast for. So there's just so much, yeah, we couldn't do that type of analysis 10 years ago, maybe 5 years ago, but there's just so many potential linkages that we can find, but we've got to identify ultimately what we're trying to get to, and then going backwards, find, the data that will get us there.
Excellent. So we're coming close to the end time here of our meeting, and typically the range or time period for our podcast. So I don't want to go too much further. Any closing compliments and comments? Obviously, Kip, thank you so much for joining us. It was a great discussion. Anyone else have anything to add?
Would it be possible to make the PowerPoint available, maybe as a download, Kip, if that's cool with you? Otherwise,
It is, yeah, no problem. I'll send that, I guess, to Larry maybe, and Larry can forward that.
We'll figure out how to make it available. Absolutely.
Yeah, we'll figure out logistics later. I just wanted to ask.
Sure, no problem.
Yeah. So one of my final comments, or some of my key takeaways here, are number one, it's not always about just having the end in mind is what I'm seeing, because I see how this model evolved. It's about understanding the discovery process, pivoting to be able to understand how to pivot, where to pivot. And I think it gets back to even something that we discussed on a previous podcast as to looking at the agile methodologies to be able to have smaller, minimally viable products or minimally viable results, for lack of a better term, relative to data and analytics. Minimally viable results are needed to be able to understand where we're going, as well as short-term trends, long-term trends, et cetera. And making sure that we have a strategic analysis perspective, whether you have someone in charge of that or whether we take that role on. Those are my closing comments.
Excellent. Well,
Anyone else?
With that, I think we can close the podcast. Again, I want to say thank you very much, Kip, for joining us, and you're always welcome back. Certainly, maybe on the other end where you can listen to some other speakers and us discuss things, and then give us some insight and guidance when we run astray. But in any case, I think it's been very informative and interesting, and I look forward to continuing to do this in 2022 with all of you actually who have joined us here. So please come on back.
Great to be with you today. Thanks, everyone.
Okay.